All right, so hello everyone, I'm Ben. I'm one of the sales engineers at NetBrain. I'm going to be showing you NetBrain's Enterprise Edition and showing you how to create an app using the DevOps. So what NetBrain does is it uses the information it collects from CLI commands in order to build that as a foundation piece on the database to create and use any of our network topology. So using all the information, we can start just by searching for a particular device we'd like to map out. Say if I'm looking for my boss WAN router, and it's going to search this database for any of this information. So it sees 156 results that match these characters that I searched for within here. And if I just want to create a map of that device, I can just go over to it. These green arrows beneath it will show me the different layer 3 and layer 2 topologies of this, where I can just select map, and that automatically opens up one of these maps for me, where I can just add any more information to this I'd like to. So since this is dynamic, I can add other devices to this by selecting these plus signs, which tells me there are neighbors that have been discovered that aren't shown on this map currently. So I can just select the device, hit enter, and that will be displayed on the map, where I can do this for any of these other devices to extend out any information that I might want to. Now I can click and drag to move this information around, and I can also zoom in on the map to gather more see more details on this diagram. So I can see routing protocols, the subnets configured on the interface, multicasting information. And I can hold my cursor over that data to actually see that piece of the configuration file that NetBrain was able to parse through in order to find out that, in this case, this interface was configured with OSPF. So I can display this information on the map as a note, and any changes I make to this aren't going to affect the configuration anyway, so I'm just adding notes to this particular map that I want to know about this device. Now, as I continue to zoom in on a particular device, I can get into the observer mode, which is a deck of cards with different information on it. So you can upload pictures to this so you can see exactly where it is in your rack, so that way you don't have to go searching for it yourself. You know exactly where it is. We have properties information we get from inventory commands on it. Again, we can see that layer 3 and layer 2 topology of the device. A design card where we can view different pieces of the device's configuration. So earlier we looked at the OSPF config, but I could look at the multicasting configuration if I wanted to, or if it was configured with BGP, I could do that as well. This performance card looks at SNMP data on the device to check up-down status, CPU and memory utilization, and on the visible interfaces that we're seeing from the map, any link errors, delays, status, also any bandwidth utilization across these interfaces. Now this last card is a history card, and what NetBrain does to collect the information is runs a benchmark, and you can have it run weekly or nightly or however often you'd like to. And you can compare the data that it collects for all the information that it gathers here, so configs, routing, ARP, CDP, and we can compare this data to see what's changed over that time. So if I want to compare the current baseline to my last week, I can do so, and it'll show me any changes that have occurred. So I can select any of these and actually open up a diff where I can see any changes to this configuration right away. And I can just select this next, so I can move through these changes to find anything that might be of interest to me. Now I can also highlight some of this data on the diagram. So if I zoom out, or even if I can't see the say the routing protocols on this, I can still highlight the information to visualize that on the map by going to highlight and go to routing protocol. And this will show me the different OSPF, EIGRP, BGP configurations. And also these dotted red lines will show me the different BGP neighbors between these devices that I can also move around to see this information here. And once I have all the data that I'd like to display on the diagram, I can easily export this to a Visio diagram. Just go to Export, and then Visio Map. And this opens up the Visio diagram that I have opened and recreates the NetBrain diagram exactly like I had it before, and it puts that into Visio. And since it's recreating the map in Visio, not just copying the image over, you can continue to edit this document from Visio itself, where you can add information from stencils. You can continue to edit the layout of the map if you'd like to. And it even comes with a legend and the time and date that we've created this map as well. So down below, we can see the map name, the time and date, and also the person who's logged into NetBrain that created the map. So it's great for your documentation purposes. Now, in addition to searching for host names of devices, you can really look for anything text-based. So you can look for an IP address, anything within a configuration file as well. So I'm going to look for a specific IP address of an end system device to see where that is located. And I can see here, or it shows up as the end system. I can select, again, those arrows beneath it. And for this time, I'll go to the layer 2 neighbor so I can see exactly which switch port that's connected to. And I can move this over to expand out the maps. And just like before, I can extend out neighbors on this as well. So I can select that plus sign and either individually grab these devices like to extend out, but I can also filter by neighbor type to say if I only want the switch neighbors, I can grab this information, hit enter, and that will display just the switch connections on the devices, where I can again click and drag to edit this map, but I can also right click and do an AutoLink to show any additional redundant links between the devices, and then do an auto layout where I can help organize this map into different core, distribution, and access layers, and I have them laid out either top down, left to right, or middle out from here. So here I have it laid out so my core devices are on the top and then my distribution devices, and I can continue to rearrange any of these ports or devices further from here if I'd like to. And also we're seeing these port channels that right now is just being displayed as the physical links, and if I right click on it, I can toggle to show the port channel instead. So that way I can know that information from there. And I can also highlight information on my layer 2 diagram. So if I go to highlight, I can highlight the LAN segments, voice VLANs, but also any spanning tree blocked ports where I can look through either all the VLANs that are being blocked or just specific VLANs on my live network that are from here. And then down below in this log, you can actually see exactly what it's doing. It's looking at the show spanning tree blocked ports command and going through that data, and then it displays all the blocked ports as these notes. So we see which VLANs are being blocked within the note, and it points directly to the interface that's being blocked as well. Now, if I hold my cursor over any of those ports, I get to see even more information. So I can see a summary of the device's configuration where I see the mode, the encapsulation, native permitted VLANs, speed and duplex on that particular interface. And just like before, I can display this information on the map as well. So in the instance of time, I'm just going to move on to our troubleshooting section. So this is more of the creating maps on demand. Yeah, of course. All right, so there's also, in the on-demand, there's also maps that you can create and have those saved, and you can organize them logically how you'd like to. So here we have it organized geographically based off sort of just continents and then down to countries and different states. But we can also, if we look at the map, My Network, go to the overview map. And this shows me exactly how I've logically broken it out. So it'll show me my network, and then broken down into the different container sites. And each of these break down further and further until we get to the very end on the leaf sites where we actually assign the devices to. And to search for any of those sites, I can just type in the search bar. So look for the Boston Data Center. And it highlights in the site pane, but also on the map from here. And I can just double click on it, and this opens up this particular site map from the last time that anyone had taken a look at it. It just takes some time to load up sometimes.
We see using the Cisco Live Wi-Fi.
Yeah, that somehow reaches here. So.
Yeah, this is the data actually sitting in the Boston data center, so it's remote access.
What's the largest network that you've mapped using your software?
The largest one is Wells Fargo will be 50,000 router switch firewall. The Barclay, the PNG is 20,000. AT&T has multiple deployments, but it's over 200,000 router switches on this thing. But it's a multiple workspace.
Yeah. And so from opening up the site, you can see from the last person that opened this up and then closed it, they saved it with the highlighted routing protocols. Now we could, and any additional information that we have on this, so any troubleshooting that we've also created on the map is all saved on this data pane on the side. So you can look at different health monitors that have been run, different show commands, and what times those are. So it's a great way to collaborate with the users, since this way, this is going to be shared between all the users of the workspace. Now, for troubleshooting, we could start out if you have an issue between two servers, say between these two IP addresses, and you want to find out what's causing that slow connection between them. We can start just by typing in those IP addresses and select path. And this puts that source IP address onto the map and finds the gateway device. And then each device along here, it logs into it and runs a series of apps in order to find what the next hop along this path is going to be. And it looks at VRFs, ACLs, policy-based routing, NATing, and also the routing tables on each of these devices in order to populate this next hop and find the information from there. And this is useful because instead of looking at your entire network for diagnosing an issue, you know right away that these are the areas that we might have some problem between the two servers. And from there, we can do different health monitors. So we can do, say, this health, the overall health monitor. We just do the run. And it's exactly like the performance monitor in that card, except instead of just running on a single device, this runs on all the devices on this particular map. And again, it looks at CPU, memory utilization, the up-down status of all the interfaces and devices, and bandwidth utilization. And if anything were showing up in red on the diagram for the data, that would mean that's past a certain threshold that we had set, and we know that we need to look into that information further. Now you can hold your cursor over these, and you can see this being graphed over time. So right now, this red line, that's the threshold that we have set at 60%. So if it went above that red line, then it would be showing up in red on the diagram. And you can leave this running over a long period of time to see if there might be any spikes in the CPU or memory utilization for any of these devices. For right now, I'm just going to stop this. And right now, I don't have any issues on this layer 3 network, so I'm going to break down to my layer 2 diagram so I can select this path that we just created and go to view L2 path. And this looks up on the ARP and MAC tables on each of these devices along this live path and stitches that together so we have this layer 2 application flow. And we can see all the devices in between here that we need to take a look at in order to find more information. So on this map, we could start out by running show commands on the devices. So we can go to run and execute CLI commands. And instead of running a CLI command on each device individually, this is going to run on all these devices at the same time to gather this information. So for this, maybe I just want a show interface. Click OK, and just click Start. And NetBrain is going to be logging in to all of these devices individually, issuing whatever show commands I'd like it to, and then exits out of these devices. And I can view the outputs just from here for each of the devices that I want to collect the information from. Now, even if I close out all of this, as I showed you earlier, you can still access any of that saved data on the data pane where you can go to any of these devices and view that show command that we ran and the date and time that it was run at. And you can double click on it to view that information. You can also click and drag it onto the map, so you have a hyperlink to access that data right from here. Now, from the layer 2 map, what we want to do is try to find if there are any errors that might be causing the slowness between them. And we could look at the show interface connection for any of the interface errors on each individually, go to the interfaces that we're seeing on the map to find this data. But this is where the apps come to play, or it can do all of the information for us. So one of them we have built out is to check for different interface errors. And this looks at a show interface command on each of the devices and then parses through the output of that command to find the input, CRC, frame, and collisions, and then populates the information onto the map itself.
And you're going to write this app.
Yeah, and then later I'll actually write the same app from the DevOps edition. But from doing this, we can actually see that we do in fact have errors between these two devices. And if we zoom in on this, we can see that we have a large number of collisions and CRC errors between them. Now, right now, that could just be that the counters are really high and we don't know if they're increased at all. And we could change the thresholds on this so that it only shows up in red if the delta is greater than 0. We can also maybe leave this running a bit longer and see if this changes at all. But right now, I can just run with the assumption that it might be increasing. And one reason for this could be a speed or duplex mismatch due to the high collisions. So one way to do that is we can hold our cursor over these to check the speed and duplex on each of them. So you can see the duplex is half at this port. And over here, we see it's a full duplex. So right away, we found that we have a duplex mismatch that's likely causing the slowness between them. But if you had 20 devices instead of 2 to check between, it would be a pain to check each individual interface for that. So again, we have an app that runs through all of the information as well. And this one is to check the interface speed and duplex, which
you have 200.
yeah, and we do have a lot of built-in apps that comes with the product that you can run that come with it, and you can run them anytime. This particular one's a bit different. Looks at the show CDP neighbor details and the show interface, and it combines these two to find any speed or duplex mismatches. So by running this, we should come up with the particular speed or duplex mismatch between these switches. But if you run on 20 devices instead of 2, you might come up with more information than you were expecting. By running this, you can see the errors down below. So again, we can see the duplex mismatch. But also, as you saw before, notes appear on the diagram with this information. So along with all the interface errors, we can see the duplex mismatch notes, where we can see that on this interface, the F1022, we have a half duplex, and the other side is a full duplex. And that's likely what's causing the slow connection between the devices. Now, the real power behind these apps is to be able to customize and create your own. And you could do it within the Enterprise Edition itself, but we also, as we were explaining before, we have a new DevOps Edition that just came out. And you can actually use this to discover 10 devices and map them out, run any of the apps that are currently in there, and even write your own. So I'm going to show you how you can write your own app very easily.
The free edition,
Yep.
standalone installation in
Yep.
PC.
Yeah, so this it's a completely new edition. It's different from the Enterprise Editions. Free, you can discover 10 devices. Here we have 9 discovered. And you can map the devices. You can run any of the information that, any of the apps that are created. And you can also write your own.
So is this a separate product on its own? Because I guess like the next step above 10 here, is it to buy the other version or is it the DevOps Unlimited?
We don't have DevOps Unlimited. This is, you're going to go to Enterprise. This is purely free.
So this runs on a single computer.
Yeah,
The other one has a centralized server.
has a server, client server structure, and a sync on.
So maybe follow on question that, how is it licensed when you look at the enterprise?
It's
is it
by
just
number of node.
Okay.
The price is $50 node.
And I noticed that it's a Windows actual installed client.
Yeah.
And you have also sync.
There's a lot of Macs here.
Yeah, I noticed.
Yeah, 6.0 will just come up with sync.
Okay.
So you
Okay.
can use the browser to get it.
Okay.
So that's
Yeah. So the first piece of when you're creating the app is to just do a general template that you want to create it from. So the one that we're creating for the interface errors, we want to monitor this to see if this increases at all. So for this template, we choose the monitor, click OK, and then this gets up into this QF execution flow. So there's different steps along here. First is just how you want to input the information. So either device or table input. But from here, we want the information from the devices on the map. So we'll just leave it as it is. The loop is so how often we're going to be running the show command to gather the information. So right now it's set to 2 minutes. We can adjust this to say 20 seconds just so it runs this more often to collect the information. And the canvas is where we actually go in to grab the information on the devices. So to get into that, you double click on it and we get into more steps to gather the data. So the first step is to the device queue. So we have either one device or you can do a pair of devices with the device itself and the neighbor. And also you can just do information from the interface itself. The next step is to choose what type of devices it's going to be running on. So you could, right now it's set to run for all devices, but let's say if we just want to run it on Cisco's. So we can select those and change the name of it to our Cisco. And when we apply this, it changes this so that we know that any CLI command from here, it's going to be running just for those Cisco devices. And you can see the logic within this. So if it's a Cisco router switch, it's going to be running any show command that we place within here. And we can also change the different device types if we wanted to that we created to get the information. Now for this, we want to first just retrieve a sample from a device that we have information about. So that way any similar output that we get from that show command is going to know exactly what to do when it gets to the map. So I can just, for now, just do a show interface command and retrieve that sample from one of these devices. And it goes into that device, logs into it, issues the different show commands it needs, and then once it has that, it spits out the output in the sample. And then from the sample, this is where we use what data we want to collect from it. Let me just make sure I can see as much of this as possible. So here we have the different show command outputs. So we can see exactly what we have from the show interface command. And from this, we want to gather certain information. So let's say if we want to get the CRC errors on this device, we can highlight where the number of CRC errors would be in that particular interface and define that as a variable. And from this, it's going to be looking for any output that's between errors and CRC, and anything within here is going to be that variable. So
Parcel is not a regular expression. You define it as you active, point and click.
and I can adjust what the variable is called, so it's not var1. I can just call it CRC, so we know what it's called. But here we can see we have 5 matches because it sees this particular variable 5 times within the output, gets repeated for each individual interface. So we want to define this under a paragraph, so each interface is its own paragraph within there. So to start out, we need to look for within the sample output where the interface identifier begins, and that's right here. So we can go within this, go to set paragraph identifier.
This is because every interface has its own CRC error. So you need to pass out multiple CRC errors on each interface.
And obviously not every single interface is called serial 00, so we can adjust this to be a variable by doing a $sign and just calling it interface. And maybe not all of them are going to be up, so we can adjust that to be the status. And when I refresh this, we can see that all the interfaces have their status and the number of CRC errors next to them, where we can gather this information.
So we basically pass it out a bunch of text to a variables that now program can use, put into the map, set up thresholds.
And you can go through the samples again just to see all the data that we're collecting for each of the outputs. And you can also add more information, say if we want to gather the input errors from there. So I'll just save this. And the next piece is what information we want to place within the table. So I can just grab all the information and move it over. And when I go to the table, I can rearrange how it's going to be labeled. So I just right click and go and move left. So I want the interface on the left side, then its status, and then the number of CRC errors. The output is how we're actually going to be displaying it in the diagram. So we want, since we are getting interface information, we want it displayed under the interface. So we want to grab the CRC errors and place on the map. But now it's saying we need to set an interface index. It just needs to know what the interface variable is called so it knows where to place that information. So we just grab our interface variable and apply it, and we can see that key next to it, so that's our key variable. And we can do the same thing with the status to have that displayed. And within here is where we can choose to display it on the diagram. And to select this, we can choose the different positions we want to place it in, so any interface position or device position will know exactly where it's going to be placed. So we can adjust this, so the status we'll put at position 1, and the CRC errors we'll put at position 3. And you'll see here exactly where it's going to be placed. Now, on top of this, obviously the number of counters on the CRC errors isn't that interesting. We want to know if they increase at all. So we want to create an alert to see if these in fact increase. So we can go to the CRC errors and have this be an error if the delta increases. So we can set if it's greater than 0, then it's going to show up as red on the diagram. We can also have a note appear on the map itself, letting us know that we have increasing errors. And that's all I need to do to build this app at this point. I can add any information from there, but now I can just save this and put it in a specific file location. So I'll put it in my created file, and I'll just call this CRC error check. And when I save it, now I can run this on any of the maps that I created. So I can just go to map all devices, and when I run this, I go to monitor queue apps, go to that queue app I just created, next, and then run, and it's going to start to collect the information on all the devices. So you can see the information appearing in front of us, where we have the status and the number of CRC errors, and we can see this down below for all the information to see if this is going to be graphed over time. We can see the changes for all of this data. And if we find that this increases at all, then this will show up on red on the diagram and a note off of the device with that alert message that we created earlier.
And you can also email the alert. Send out an email, say, find an alert, email.
Yeah, so here's the alert that just popped up. So we have that showing up in red on the diagram, and this is the amount of alert counters that we have for that device. And then here's the timestamp of within that note of what the actual error was. So here we have the increasing CRC errors on that device.
It means the cable of bat or duplex is a mismatch. So you just wrote that app, actually, it would save you a lot of time. You can run this app over 10,000 links or 10 nodes, 10 links. Doesn't matter, instead of type the command. And this app can be used by anybody. Who have a Cisco router. Let's say you have a Juniper router using different command. All you need, what Ben just did, drag a Juniper branch and type a Juniper command, and using the visual parser, pass the command, and now this app will work with multi-vendor product. So that's it.
Yeah, that's all.
I actually have a question from Twitter, more back on the documentation side of things, but the question was, can NetBrain pull CDP neighbor data from all of my switches and spit it out into a CSV or XLS list?
Oh yes, absolutely, for sure. Yeah, that's a, we call it reporter picture.
That's not even a hard one. What are you talking about?
That's a simple one. Yeah. There's a lot of capabilities this can do. This actually has a, we call it video programming. If you check network thing, you always do a pair, right? This device and a neighbor device, you actually can program this neighbor chat across your entire network without writing one line of code. So we're actually building that network programming into this video environment. And to show you, like if you check the duplex mismatch, you're checking the neighbors across your entire network. So a lot of cool things you can do with point and click. You know, no line. You notice there's no regular expression involved. There's no data structure involved, right? You know, the arrays, all the things. It's some table, it's sample-driven programming, stuff like that.
And is discovery CDP, LLDP, or both?
You can do both. CDP, LLDP, routing table enable, MPLS enable, a bunch of discovery anything there. Yeah. Ben just described a app technique. How long did it take you to learn this app?
Well, yeah, I don't know. It took me a morning, I guess.
Yeah. So Ben is not a programming,
No.
he's a network guy. So